Welcome to Lesson 61, Part 2. So we were playing with a lot of physical parabolas in 61A. We had, like a suspension bridge or something. That cable, it turns out, pulls itself into the shape of a parabola. We had, like, if you hit a baseball through the air, it follows a parabolic path. Or you can think of like a water fountain. If you turn on a water fountain, the water columns are going to do these nice parabolas and so on. Anyway, we were playing with that last time. But what I wanted to show you in this time is some business applications. Optimization is the real key word, I think. Optimization, where you're trying to get maximum money or minimum cost or something like that. Those are called optimization problems. Here's an example of one right here. Biff is getting ready to harvest. So Farmer Biff, whatever he's got, he's harvesting it. And he's got this trade-off to consider, because if he harvests now, you'll be able to reap 100 bushels. Skip ahead. And if he waits a week, he'll get 2 more bushels. Sounds good, right? You just hold off. Don't harvest yet. The more you wait, the more you're going to be able to harvest, the more you're going to be able to sell. On the other hand, look at this action. If he harvests now, we'll be able to sell them for $4 each. Yee! But the price goes down 6 cents for every week that he waits. Okay, so you see 2 things happening. The amount that you harvest is going to be able to go up if you wait, but the price that you get is going down if you wait. So what we should do is we should look at these 2 things separately first. So the number of bushels or whatever harvested in an acre, per acre. It's something that I always think graphically. It's like as weeks go by, it's changing. I mean, right now, if no weeks go by, if you're talking about now, what's it say, 100 bushels? Yeah, you're going to harvest 100 bushels. But that's changing. As the weeks go by, every week that goes by, you're going to get 2 more. So if you wait 1 week, it's up to 102. If you wait another week, it's up to 104. You wait another week, it's up to 106, and so on. Hey, does that make you think of our straight line stuff that we've done in the past? Can you tell me the slope of that line? Come on, man. What's the slope of that line? Well, it's the old, you wait 1 week, you get 2 more bushels, right? 2 more? Yeah, okay, good. 1 week, if 1 week goes over, you take a step to the right by 1 week, you're going to go up by 2 bushels. And so your slope is 2. So notice we can write the equation of this right now. How many bushels are we going to harvest? Well, it depends on how many weeks have gone by. And it depends like this. Start at 100. And the slope is 2. Add 2 per week. Ain't that nice? I suppose mx plus b form, you'd write it this way, but you get the idea. Start at 100 and keep adding 2 every single time. All right, that was nifty. Now we got to look at the price. The price is doing something else. The price is going down. So I'm going to think in terms of a graph again. So here's X weeks go by. X weeks go by. So if no weeks go by, if we're talking about right now, the price is $4. So I'll put that right here. Okay. Sell them for $4. Yep. And then every time you wait a week, it's going down 6 cents. Down 6 cents. So if you wait a week, it's a little bit less. If you wait another week, it's a little bit less. If you wait another week, it's a little bit less. If you wait enough weeks, I guess it's going to be free or whatever. They won't buy it, I guess is what you're saying. But anyway, what's the slope of this line now? Every week that goes by, you go down 6 cents. That's a negative slope for one thing. So every week that goes by, the price is going down by $0.06, if you will. So that's cool. We can write a nice little function for our price. The price is, well, start at $4 and subtract 0.06 cents every week that goes by. So if you wait 2 weeks, you'll subtract 6 cents twice and so on. Okay, so this is really nice. This is coming together really nice, I think. We got these 2 formulas already. Now, how is this going to help us figure out the best time to harvest? Well, what we're interested in doesn't say it explicitly, but I think you know. When would be the ideal time to harvest? Well, it would be when you're going to get the most money. And you get money when you take however many you've got and you sell them. This is kind of like, I got this many to sell and I'm going to get this much each. Notice you can multiply those two together to figure out how much money you're getting. That'll be called the revenue. And so let's actually switch colors and write that down. Revenue is going to be the number of bushels sold or harvested in order to sell them times the price of each. The revenue function is going to be take the number that you're harvesting function and multiply it by the price function. Just multiply these two things together. So it's 100 plus 2x over here. And the P of x is a $4 minus 0.06x over here. And in some sense, we've just written our revenue function. Although I'm going to multiply it out. I like the idea of a polynomial in standard form. So foiling here. 100 times 4 is 400. Pardon me, 100 times the minus 0.06x. That's a minus 6x. This is giving me a plus 8x. And then I'll have a minus 0.12x squared. So if I rearrange this thing as a polynomial in standard form, you would put the negative 0.12x squared first. Then you'd put the plus 2x, and then you'd put the plus 400. There's our revenue function. Now this is the part where it's knowing what you've got in front of you. What's that? Seems like a fair question. We derived it. It's the revenue function. I guess you could say that. But what's that? What's that equation? What is it? You know what that equation is? It's the equation of a parabola. No, ain't it? It's a parabolic. It's a parabola. It's a quadratic. It's got an x squared, basically. It's a polynomial degree 2. It's a parabola. Which way does it open, up or down? Well, you see the negative there tells you that it opens down. We've got a parabola that opens down. That means if it opens down, it's going to have a highest point somewhere. In fact, when x is 0, notice when x is 0, this goes away, this goes. You're starting at 400, which is basically saying you'll get $400 if you sell them right now. Does that make sense? Let me scroll back up here. If we sell them right now, well, we're getting 100 per acre, $4 each. That'd be $400, wouldn't it? Yep. So if we sold right now, we'd get $400 per acre, I guess. And it's a parabola that opens upside down, and it has a highest spot somewhere. So the graph has to look something like this, and there's a vertex here at some value hk, right? Isn't that slick? And so knowing that that's the picture that's kind of going on behind the scenes, you can say, oh, I should be able to figure out what h is, right? Remember, h is the x-coordinate of your vertex. If I solve for h, I've got the number of weeks to wait in order to reach this peak value here. How do you find h? Oh, we remember how to find h. There's a nice formula for finding h. If you've got your parabola in, this is called general form of a parabola. This is a little confusing. It's the standard form of a polynomial, but for a parabola, this is called general form. Yeah, whatever. Anyway, you do them negative b over 2a is what you do. So I got a negative. My b is this thing in the middle, the 2. That goes on top. 2 times the a. The a is a negative 0.12. And if you work that out, which I did, what I get? I got an 8 1/3, basically. 8.3, 8 1/3. You should wait 8 1/3 weeks. Best time to harvest is in 8 1/3 weeks. There's the answer to our problem. Now, if you wanted to, you could figure out what is going to be our revenue at that time anyway. Just take that 8 1/3, plug them in here. You'd be solving for the k, right? Is what you'd be doing. If h is 8 1/3 and you plug the h in, you're solving for the k. Did I do that? I did do that. Cool. When I did that, I got k is equal to 408.33. So that would be dollars per acre. So right now, if you harvest, it's $400 an acre. But if you wait 8 weeks, you can get $408 per acre. And if you're a farmer and you have 8,000 acres, you might want to get the extra $8 an acre. Why not, right? So anyway, I think that's a beautiful example of an optimization problem. It turns out to be a quadratic. because this was a straight line that was going up and this was a straight line going down, and we wanted to basically multiply these two straight lines together, I think that's kind of interesting in itself. You multiply the two straight lines together, you end up with this parabolic revenue function. Well, it's a parabola. It's got a vertex. Let's find the vertex because that's the point where we maximize our revenue. Cool. So, I think that was cool. Huh. You happy yet? I'm happy. All right, let's look at another one. This one's, it's the same idea, but it's phrased a little differently, I guess, and so you put it together maybe a little bit differently and so on. So this is where you have to basically just gain some experience playing around with a lot of problems so that after a while you start to say, oh, I know what to do. I'll do this. Okay, so this is not exactly a farmer. This is a ballet slipper guy. Sergei, he sells ballet slippers. $55 each, per pair, I should say. Cool. And at that price, he's selling about 40 pair every week. Cool. So he's making, what, $2,000 a week or something? Is it that much? Yeah, I guess it is. So anyway, he estimates, because he went to marketing school or whatever, he estimates that for every dollar that he shrinks his price, he'll sell an additional pair every week. So it's like, okay, so right now, and sometimes I just kind of like to write things out just to sort of help myself think it through and try to pick up the patterns and stuff. But anyway, right now, the price is $55 each. And he's going to sell, well, he is selling 40 pair per week. 40 per week. And so 55 times 40 is, let's see, 22. Yeah, it's $2,200 that he's making every week. Wow. That's a lot. But he's figuring that if he reduced his price by $1, right? That's what this is saying. For every dollar he reduces the price, he'd sell one additional pair. So he would sell not 40, but 41. Well, what's 54 times 41? I don't know. Let me grab out Mr. Calculator. 54 times 41 is, ooh, look at that, an extra $14. Worth considering. Let's do that again. $53, 42. Right, so every time the price goes down $1, he's selling an extra pair. So this goes down, this goes up. So what's 53 times 42? Mr. Calculator says it's 2226. Oh my gosh, we're going up. We're still going up. Okay, cool. So I suppose if you wanted to do it brute force way, you could just keep making your table and keep going forever. But there's a very elegant way that you can do this, and that's to use the algebra. Similar to the first problem, you kind of go like this. Okay, I'm going to build a revenue function again. And the revenue is going to be basically the price times the number sold. And right now, the price is $55. And what I'm thinking of doing is reducing the price by $1, or maybe $2, or maybe $3, and so on. So what you got to do is you got to say, okay, what am I going to say that my X is? Let X be the number of dollars we reduce the price. That works, right? So if you reduce the price by $1, X is 1. And if you reduce the price by $2, X is 2. That makes sense, I guess. And then the number of sold is going to be, well, you're selling 40 at the moment. And notice I can use the X here. Even though I was using X for dollars, this is gonna, well, here it stands for how many extra pair did I sell. But since it's a one-to-one thing here, reduce the price $1, add 1 pair. I can just use that same X, even though it's kind of standing for, it works, right? You've reduced the price by $1, you're going to sell 1 more pair. So if this goes down by 1, this goes up by 1. If this goes down by 2, this goes up by 2. If this goes down by 3, this goes up by 3. It works. So I'm going to stick with this definition, what I said in the first place, that X is the number of times I reduce the price $1. You might say it that way. Well, we can work this out now. It's going to be a parabola. Let's just kind of FOIL it out here. 55 times 40. Don't we just figure that out? Yeah, that's 2200. Outside is a plus 55x. Inside is a minus 40x. And the last terms is a minus x squared. So if I arrange this polynomial in standard form, I'd have a negative x squared plus a 15x plus a 2200. There's our revenue function. And lo and behold, what have we got here? We've got ourselves another one of these parabola type things. A parabola opening down, which means there's going to be a high point somewhere. The vertex is going to represent the top of the parabola, so to speak. Now notice when x is 0, that's 0, that's 0. We're starting at 2200 right here. That's how much he's making right now. Oops. Put that back. Okay. Let's uncross those out. Okay. And it's going to, well, we saw that it was starting to go up right here, right? So as x went up by 1, our revenue went up a little, then our revenue went up a little bit more, and so on. So our revenue is going to start going up a little bit, but then it's going to have to turn around and start coming back down. So here's our vertex at HK. Okay, cool. So once more, you want to find your maximum revenue? Well, it's occurring here. It's occurring at the H. The x-coordinate of the vertex is called H. It's occurring at the H. And where's the H? Grab out this here formula again. Negative b over 2a. Negative. The b is a 15. 2 times the a is a negative 1, right? There's the a, there's the b. And that's going to be a 7.5, right? Positive 7.5. You should reduce this price by $7.50, I guess. By $7.5, which is, yeah, reduce the price by $7.50. Was this a Sergei? This was a Sergei. Sergei's best price will be, okay, now remember what X stood for. It stood for how many dollars did we reduce the price. He was selling them for 55 bucks. So 55, take away 750, it's going to be 47.50 each. That's kind of the answer. Now let me make sure I'm answering the question as it was stated. Come back up here. Okay, what price would maximize his revenue? Got it. How much more would that be than what he's making now? Oh. In other words, what's his revenue here? Want to plug the 47.50 into the revenue function. So negative, take your 47.50 and square it. Plus 15 times your 47.50. Oh, wait a minute, that's not, ooh. Caught myself. Remember what X is. X is not the price. X is the number of dollars. I'm using this for my X here. So the revenue at 7.5, that's what I want to use, is negative 7.5 squared plus 15 times 7.5, okay, plus 2200. And did I work that out already? I came out to 22.56 and a quarter. And that, by the way, is the same as your K, right? It's the Y coordinate here. So he was making 2200, because remember when X is 0, that's your Y-intercept. He was making 2200. Well, it says it right there. He was making 2200. This is 2256. An additional. What would that be? 2256. Is that really all? Is that really all? That seems like I should be making more than that. Anyway, an additional 56 bucks a week. Well, it's better than nothing. 56 bucks a week. Well, this was already 26, so yeah, I suppose. It seems like an anticlimax to me. I was expecting a lot more than that, but whatever. Maybe Sergei, maybe you should, I don't know what. I don't know anything about the slipper business. Well, you kind of get the idea. So the H represents the best number of dollars to reduce his price, and the K is going to be the revenue at that value of H. Okay. Now this third one is pretty similar, but like I say, what makes these different is basically the wording can be a little bit different, and so your setup can be just a little bit different, and it's an art form. This is where practice comes in. You see enough of these problems, you think about how you want to set it up, you get a little experience setting it up, and pretty soon you get pretty fearless. You're like, well, I'll figure out some way to set this up. That's what we're aiming for here. So anyway, this one, it's an Olga. She's selling borscht, 200 bowls a week, $4 per bowl. She's going to sell extra bowls if she reduces the price. So it says 8 extra bowls for every nickel reduction in price. So this is similar to the Sergei. It's a little different. It's not $1 for an extra pair. It's 8 bowls for extra nickel or whatever. Anyway, what price maximizes her revenue, and how much more would she be making than now? I wholeheartedly ask you to, or encourage you to, try this yourself, because you learn a lot more by trying and getting stuck than you ever do by just watching somebody and going, yeah, whatever. Yeah, whatever. That's not how you'll learn. You have to watch, get stuck, and then get surprised at, oh yeah, that's how you do it. And that's how your brain remembers things, right? Pause. Rewind or whatever. Okay, here we are. What do we got? 200 bowls of Borscht. Yep. $4 per bowl. Okay. I can figure this out that right now she's selling 200 bowls at $4 each. So that's $800 a week, right? Okay. Now she's going to sell 8 more bowls. So let's see now here. The revenue that she'll get when she monkeys around with her price. This is the revenue now. But she's going to monkey with the price, right? So let's see. An extra 8 bowls. An extra 8 bowls. And I'm just leaving that there for the moment. For every nickel reduction in price. And I'm just kind of leaving that there for the moment. So this is like if she did it once. If she reduced the price to $3.95, then she would sell 208 bowls. And you could multiply 208 times $3.95 to get the new revenue. If she reduced it by another nickel, that would be $3.90. She'd sell another 8 bowls, and so on. And you could multiply those two to figure out the new revenue. And if you really wanted to brute force your way through it, which would get you there sooner or later, but it wouldn't be very elegant, well, you could do that. But here's what we can do that's kind of nice and slick and actual gets you right to the answer right away. Boom. I'm counting how many times I reduced it. Stop. Go down. How'd you get here? Go down. Okay. So anyway, I'm counting how many nickels, right? This is reducing it by 1 nickel. This is reducing it by 2 nickels, reducing it by 3 nickels, and so on. Why don't I make that my x? Right there. So x is the number of nickels price has been reduced. Or the price gets reduced or whatever. X is the number of nickels. So if you reduce the price by 1 nickel, what is going on? If you reduce the price by 1 nickel, it's $3.95. If you reduce the price by 2 nickels, then obviously it's going to be $3.90, and so on. So X can just be the number of nickels that we reduce the price. Now, if we reduce the price by 1 nickel, it goes up by 8. And if we reduce the price by 2 nickels, it goes up by 8 times 2. And if we reduce the price by 3 nickels, it goes up by 8 times 3. In other words, I can put the X over here. And it all works just right. I mean, the way you check yourself to make sure your formula is working is you just kind of say, okay, I think that's going to work. Let me just double check here for a second. Let me just take a moment and double check. So if I go down by 1 nickel, this will be a 208, because I'm plugging a 1 here. And this would be a, because I'm plugging a 1 here, this would be a 395. Okay, cool. And if I reduce the price by 2 nickels, what is my formula saying? It's saying 200, and if I plug a 2 here, that's going to be a 216. And if I plug a 2 here, 0.05 times 2 is a dime. That's 390. Yeah, it's working. It's working. The formula's working just like I want it to. Which means I have just written down my revenue function. Now let's multiply it out. Get it as a polynomial in standard form. 200 times 4 is an 800. 200 times that is a negative 10? 10x? Sure. And then 8 times this, that's a 32x. And then this times this is a negative 0.40x squared. So put this as a polynomial in standard form. Means put the x squared term first, put the x term next, put the constant last. There is our revenue function as a polynomial in standard form. It happens to be a parabola in general form, but we know that it's a parabola because it's x squared. It's a degree 2 polynomial. Its negative lead coefficient means that it opens upside down, which means we know we have a rough idea what the picture is. When x is 0, notice you're starting at 800 here. And that was her original, if she does nothing, she's going to make $800 a week. We expect this to kind of go like this again. Boink. There's going to be a vertex where we have a magic number h that maximizes our revenue. H is negative b over 2a is negative. The b is here, 22, 2 times. The a is here, negative 0.4. And if you work that out, which I believe I did, didn't I? Yeah, I did. 27.5, which is a little awkward. She has to reduce the price by 27.5 nickels. Oh well. We'll just do it. We'll pretend that that's possible. Well, you got to it's going to be rubles anyway, right? So it'll probably work. So anyway, 27.5 is the H. So best price is reduce by 27.5 nickels. How much is that? 27.5 nickels? i.e. reduce by $1.37.5. And so it was $4. So you take the $4, subtract that, and you get $2.62.5 per bowl. Maybe you have to buy 2 bowls at a time. I don't know. Anyway, there's a new price. That would be the optimum price for Olga here. So that's quite a reduction from the $4, right? So she's going to make a lot of money, I think. Let's find out how much. R of x using h equals 27.5. Okay, so we go negative 0.40 times 27.5 squared. Remember, to get the k, you're going to plug the h in. You just got this is your h. You just got the h over here. You plug that in to get your k, right? Which is going to be representing your maximum revenue. So negative 0.4 times the 27.5 squared. Okay, cool. Plus 22 times the 27.5. Okay, cool. Plus 800. Okay, cool. What does that come out to be? I don't think I have this figured out. So here I go. Negative 0.4 times 27.5 squared equals plus 22 times 27.5 equals plus 800 equals, oh yeah, now we're talking, 1102.50. See, now that's nice. Why make $800 a week if you can make $1,100 a week? Apparently Olga can, if her market research is correct. So it's all about the parabolas having vertices. So if this is your revenue and you know it has a peak, you want to find it, right? Which basically means you want to know somebody who knows how to find the H. Or I suppose you could have done this brute force using a Excel spreadsheet or something, but sometimes the formulas are much more handy to have, much more handy to play with anyway. Certainly the skill of being able to set up and solve formulas, that's what we're aiming for in this course. All right, I guess that's it. Yay. Go do some homework, will ya? Get some good practice.